In order to answer or solve the problem from the previous slide, let's go ahead and answer some questions. So A, which shapes have a pair of sides that are always the same distance apart? Well, we've learned some vocabulary that is a word that means exactly lines or sides that are always the same distance apart. That means lines that are never, ever going to cross each other. So an example of lines that would never ever cross each other would be something like a line that goes like that and a line that goes like that. If I extended those lines forever and ever and ever in both direction, if they were perfectly straight, which drawing them by hand doesn't really give you exactly straight lines, but if these lines were actually exactly the same distance apart on both ends, that means from this end to this end and this end to this end being exactly the same distance apart from each other. What do we call those? We call those parallel lines. So A says, which shapes have a pair of sides that are always the same distance apart? Well, let's look at shape A. What about this side and this side? Do those follow this question? Shapes that have sides that are the same distance apart? Well, if you had a ruler, do you think that this side and this side and this side and this side, do they look like they're the same distance? Is that the same distance? Yes, it is. Okay, same distance. What about the other two sides of the shape? This side and this side. Okay, we said that when they're the same distance apart, that means they're parallel. Are these two sides the same distance apart from each other? If I extended these sides, would they ever cross over each other? No, they're always going to be pointing in the same direction as each other, never ever cross over each other. So, which shapes have a pair of sides that are always the same distance apart? I know that A does. Let's see if any of the other ones do. A definitely has sides that are the same distance apart. What about shape B? Okay, there's lots of sides to this shape, but let's just look at two sides of it. This side and this side. Are those parallel with each other? Yeah, they sure are. What about some other sides of this shape? What about this side and this side? Are they parallel? No, because they cross over each other. That means they're not the same distance apart from each other. But what about this side and this side? Yep, those two are. And if we did the same thing with the other two sides that face each other, we would see that those are parallel as well. So this guy is also answering question A, which shapes have a pair of sides that are always the same distance apart? B does. What about shape C? Well, let's look at this side and this side. Are those sides the same distance apart? Sure are. If I had a ruler and I could measure from this side to this side and from this side to this side, they would be the same distance apart. Same with the other two facing sides of this shape. Those also are parallel. So yes, shape C also has sides that are always the same distance apart. What about shape B? Well, this side and this side. Oops, that's a horrible line. Let me try that again. And this side. If you had a ruler and you measured from here to here, and you measured from here to here, are they the same? Yes, yes they are. The other two sides would have the same answer. So yes, that guy has sides that are always the same distance apart. What about our triangle here, shape D? This side, and let's choose this side. Are those the same distance apart? No, because if they were, they would not cross each other. They would not intersect, but they do intersect. And that means they're not the same distance apart. Well, let's try this side and its other side. Let's try this one. Are they the same distance apart? No, they're not, because right here, we call this intersecting. Okay, they cross over each other. So they are not the same. So to answer question A, which shapes have pairs of sides that are the same distance apart? A, B, C, and E all have sides that are the same distance apart. All right, let's see. Question B. Lines, line segments, and rays that are always the same distance apart and never cross are called? Well, what did we just say? I just said what that was called. Who remembers? What did I say that that is called? That is called parallel. Okay? When you have sides that are the same distance apart, we call those parallel. Okay? Parallel sides. So let's look here at question C. Which shapes have a pair of sides? Oh, why is that crossing over here? Let's raise that up so we can see. All right, which shapes have a pair of sides that form a right angle? We should all know what a right angle looks like, right? So when we have a right angle, it comes straight down and straight over, creating how many degrees here if we measured it? 90, right? 90 degrees. So what it's asking is, which shapes have a pair of sides that form a right angle, a 90-degree angle? Well, if you have a post-it note handy, you would be able to put it on the screen and see that this is a right angle, as are the other 4 angles that are created in this rectangle. And we've also talked about the fact that all rectangles and all, what? Oh, squares, yeah. All rectangles and all squares have a pair of sides that form a right angle. So let's think about this guy here. This has 1, 2, 3, 4, 5, 6 angles, and these are all equivalent. These are all the same angle. If you look at them, every one of these angles is the same. So let's just look at one of them. Is that a right angle? No, that definitely looks greater than a right angle, meaning that it's an obtuse angle. All right, let's look at this guy. Well, this has an angle here, but that does not look the same as these 2 angles. Let's see if any of them are right angles. Well, this one here, what do you think? Does that look like a right angle? No. That looks smaller than a right angle, doesn't it? And if you had a post-it note and you put it up in that corner there, or if you had a protractor, you'd be able to see that that measures less than 90 degrees. What's an angle that measures less than 90 degrees called? Acute, that's right. All right, so this one, that looks identical to me. These 2 angles, they're identical. So that if this one's acute, that means this one is too. But we've got this angle here to look at. So if you have anything handy that has a square corner, you'd be able to see what type of angle that is that we have. So let's see, let me grab a square and let's see if we can decide what type of angle this might be. So if I grab this guy here and let me rotate him so that he fits into that corner there really nicely. Ooh, does this square corner here, this right angle on this square, does it fit into that angle? Well, that looks like that fits perfectly to me. And if this is a square, we know that that's a right angle, and it fits perfectly into the angle of this triangle. So what does that mean about this angle? That means that it is a right angle. So we know that the square has a right angle. We know that the rectangle has at least one right angle. This triangle has one right angle right there. And I bet that a lot of you looked at that angle and said, no, that's obtuse. How many of you thought that that was an obtuse angle? Sometimes it's tricky when you're looking at them and they're kind of upside down looking, but if you grab a post-it note or a square corner of any sort and put it in there and it fits perfectly, you know that's a right angle. All right, what about this guy over here? Well, let's see. I've got my square here, so let me just test this out. Can I fit this corner into any of these corners? If I line up one side of my angle, Does it fit perfectly? Look at that. Look at all that extra space there. That means that this angle right here, that's an obtuse angle. All right, let's try this angle. Oh no, look, that lines up, but look, I'm covering up that side of the angle. That means that this is an acute angle. Same over here, that's an acute angle. My right angle is covering up part of the other angle. That means that that's acute. And line this one up. I've got my vertices lined up. I've lined up one side of my angle, but look, there's all this extra angle over here. That means that this angle here is obtuse. So this shape here, my rhombus, does not have any right angles. So A, C, and D all have right angles. All right, let's look at D. Lines, line segments, and rays that form a right angle when they meet are called, what do we call those? Lines, line segments, and rays that form a right angle when they meet are called what? "90 degree angles." All right, so let's discuss. Move on down there. Oops. All right, let's discuss the last one here. Explain how you could test your choices. We already talked about how we could test them, right? We can grab a square corner of some type, a 90-degree angle, on a Post-it note, or corner your paper, anything that you know is a 90-degree angle, and you can fit it in there, all right? You can just put it right there in that corner, and you can test it. If that angle that you're testing is less than the corner, smaller than the corner of your Post-it note, it's an acute angle. If the angle that you're testing is greater than the corner of your Post-it note, it's an obtuse angle. Very good. So we can test it with something that we know is a right angle. And also for the parallel lines, how can we test those? Well, we know that we can test those by extending those lines. So for instance, if I extend this line and make it much longer, and if I extend this line and make it much longer, they can go on forever and never ever cross, right? They're the same distance. So if you extend your lines and they don't cross over, you know that they are parallel. So, and we can test that with this guy here. If I extend this line and I extend this line, oops, hold on, and I extend this line, we know that those are not parallel because of the fact that they cross over right there, okay? So that's how we can test our choices. All right, I think that we have looked at all of these shapes and we are ready to move on to actually answering our question.